What's the Cypro Advanced IP? What markets do you actually focus on? What does that actually do?
So the advanced interface IP we have in the Cypro product line includes PCI Express Gen 1 and Gen 2, HDMI and DisplayPort, as well as MIPI IP solutions.
So it's all the I/O that you work with out of an SoC?
Yeah, multiple type of interfaces which are common in telecom, consumer, and mobile semiconductor.
What challenges do you find there? Are there bottlenecks? I mean, is that what you're overcoming?
What we see more and more from the customer that we engage with are that analog interfaces is complex and very difficult to do, especially on advanced process nodes. So we see the need in having a proven interface IP available from a trusted partner like Virage Logic, that we can get that to them in the right time frame. They can use it off the shelf and then focus and concentrate their resources on differentiating their product line and get to the market like that.
Are your customers looking to build everything onto the most advanced digital process, mixed signal type of chip, or are they also working off chip with a separate analog chip at potentially an older node?
So it depends on which platforms we're talking about, but typically on the higher end protocols we see higher and higher integration. So multiple interfaces are required to be operational at the same time. So this really brings a lot of challenges for the design team to get the expertise in-house and to line up all the proven technologies all together to meet the right deadline, get to a proven silicon, and actually get to the market at the right time frame.
What kind of challenges are your customers running into? What are you hearing out in the marketplace that has to be solved?
So meeting the standard, making this IP work as a complete solution from the PHY, I/O, PLL controllers, have a verification suite attached to it, all of that available from a trusted vendor that they can just plug and play that into their SoC, so they don't have to worry about how do I design it, how do I test it, how do I make it run. So the value that we bring into the market is production-proven IP, which is from Virage Logic. So all of the IP that I mentioned are currently used in the production processors, either a graphics processor or application processor. So they have the confidence of getting an IP which is used right now in mobile phones, for example, and really they don't really need to worry about debugging it for their own use.
Are you being called upon to do more pieces of IP, particularly maybe analog blocks than you were in the past?
Yeah, that we do. I wouldn't call it analog blocks. I would call it interfaces. There is a proliferation in the interface market. That, for example, MIPI has become an umbrella of interfaces that are now being introduced to the market, and each SoC going into a mobile phone will require to support that. So we're talking about D-PHY, M-PHY, HSI, CSI, DSI. There's an abundance of 10 or a dozen standards that are upon us. HDMI, DisplayPort, MHDI, there's a proliferation of interfaces that are coming into the market, and tell the truth, SoC designers cannot follow all of them, make all of them work on the right process node on the right time. They have to rely on a partner like Virage Logic that they can get that IP from.
Another part of the problem is that I've been hearing out of chip designers is that trying to build all these different interfaces into the chip and still keep the power down is a major problem. Are you finding that as well, and what do you do about it?
Yeah, we do find that, especially in standard-based interfaces, the number one criteria is getting it to me available, proven, and of course meets the standard. So that's a criteria you must do. But second is area, power, and actually manufacturability. All these type of three elements are important. How important they are depending on which application you're talking about. The mobile market specifically requires as low as possible power, because it is a battery operated device. The least power you consume, you can actually have higher value to your end customer. So, for example, with our MIPI solution, the fact that we have a production-proven technology means also that it is optimized for area reduction and power reduction, because the implementation that we have selected in implementing our DeFi approach is only the minimum that requires to operate a camera, or only the minimum that requires to send the pixel to the display. So effectively you can see 70% area reduction compared to alternatives, 80% power reduction compared to alternatives, because the optimized approach that we have chosen to implement.
You talked about manufacturability, but we're talking also about standards and standard IP. What changes there? Why is some IP not manufacturable?
So it's not the case of not manufacturable, but typically when you get a solution from an IP company, it is silicon proven. It means that it was designed for silicon and you can actually test it. But IP provider typically stop short at really going into production. However, semiconductor companies do take this IP and move it to production. Now, with the challenges going to 40 nanometer and then 28 nanometer, yield is, at least at the beginning, is unexpected. So if you add a circuitry to your IP that really takes that into account, so like calibration circuitry that we have added to our MIPI DeFi allows them to really control the yield and possibly regain some yield loss due to some tweaking of the process. So this typically is a phenomenon, you know, when we go to a higher process node that after a while just goes away. But the fact that you can really control the on-die resistor on our DeFi really allows you the flexibility and allowing you to really not only have the smallest design, the lowest power design, but also to have enough devices available for you to ship to your customers, especially during ramp-up.
Hezi Saar, thank you very much.
Thank you.